Hello, class. It's now time for Envisions Math Lesson 9-7. So for this lesson, you're going to work on drawing a picture and writing an equation. Now, drawing a picture. Normally when I think of those words, I think of doodling a happy smiley face or some nice stick figures or whatever my artistic abilities can express. In this case, however, when you're drawing a picture for Envisions, it's asking you basically to draw a table, okay? And I'll show you what I mean in just a minute. Besides drawing a picture, you also need to write an equation, okay? So as you read a word problem, you're going to determine what the equation is going to be to help you solve the problem, okay? So I'm going to show you the example that's actually given in the book on the Reteaching 9-7 page. But here we go anyway. I started drawing a picture over here, but then realized, that's not what Envisions wants me to do. It wants me to draw this type of picture, okay? I'm going to read the word problem that has brought about this picture and this equation. Pippa filled 1/8 of a jar with blue stones, 1/4 of the jar with yellow stones, and 1/2 of the jar with purple stones. How much of the jar is filled in all? Okay, so I looked at the question. It's even good to reread, correct? And then after reading the question, reading it over again, I've determined that this is an addition problem. Okay, so my equation is going to have addition in it. Why? Because it gave me amounts and it said how much in all. Okay, so I know that this question is asking me to add. It also gave me 3 specific fractions in order to fill this jar, right? This jar of purple stones and yellow stones and blue stones. So I need to draw a picture. Now, to be honest, you could, in this instance, probably draw a nice little jar, have half of it filled up, representing 1/2, the fraction 1/2, and then 1/4 of it marked off with yellow stones and 1/8 marked off with blue stones. You could have done that. You can do something like that. In some instances, though, it's much more difficult to mark off where the fraction should be. So one picture that you can draw for this assignment would be to draw a table, okay? This table is representing my jar. X is representing my entire jar, okay? I've marked off half of the jar, okay, and used the fraction 1/2 for my blue stones. I've marked off 1/4 of the jar representing the yellow stones, and then I've marked off 1/8 of the jar representing the blue stones, okay? Now, I got to tell you, this isn't quite to scale. I didn't use a ruler to measure this off, but this is somewhat accurate. Now, again, the word problem said how much of the jar is filled in all, and it gave me 3 different fractions, okay? So I have 3 different fractions here, and I am adding them together. However, yes, this unit has unlike denominators, correct? So we have 8, 4, and 2, okay? Now looking at all of these, my least common multiple for all of these is actually 8 in this instance, okay? So I'm going to convert all of these fractions to have a denominator of 8. So let me do that really quickly. If I had musical interlude right now for you to listen to while I'm writing, I'm sorry, that sounds horrible. All right, here we go. So I have changed the denominators all to 8. Now I need to make sure that we have equivalent fractions. Now since 1/8 already had a denominator of 8, I could keep the numerator 1. Now 1/4 becomes a fraction with the denominator of 8. To get from 4 to 8, you multiply by 2, so you have to multiply the 1 numerator by 2, and that equals 2. So that fraction becomes 2/8. And then 1/2, right? To get to 8, well, 2 to get to 8, you multiply by 4. So you multiply the 1 by 4, and you get 4/8. So in this instance, our equation comes out as 1/8 plus 2/8 plus 4/8 equals x. And why do we put x there? Because at this point, the answer is unknown, okay? However, yes, there's always a however sometimes. Well, I shouldn't say there's always a however, but often there's a however. If you look at the questions that you are working on today, the directions say draw a picture and write an equation to solve. So it would be wise of you to also solve this problem. In this instance, we have 1/8 plus 2/8 plus 4/8. 1 plus 2 plus 4, 7. And then 8 plus 8 plus 8. Oh, do we add the denominators? No, if they're the same, remember the denominators stay the same, okay, in the sum. So we have 7/8 is our answer, okay? And that's why that guy's so happy, because he knew we were going to solve the problem, all right? All right, everyone, make a great lesson for lesson 9-7, okay? We'll see you later.